Science. Oh, hello Hannah, sneaking in at the last second. Hello Leo and Margot. It's a lesson on reflections. This is amazing, this, right? So I'm Lara, welcome. If you're new, this is Theatre of Science. We've been meeting here for, about 3 years? Just doing like free lessons like this. I will tell you at the end how you can pay me. There's no point telling you that yet. You might not enjoy it. You might leave halfway through, so let's just get on with it. Look around the room, right, wherever you are. Everything you can see, you can see because light is bouncing off it and into your eye. Which is super weird when you think about it, right? Because your eyes are quite small. Like, you would think that there would be something where light just happened to not bounce into your eye, right? To like miss your eye. But if you look around the room, it sounds obvious, you can see everything, can't you? So light is bouncing off everything and into your eye. Like, there's no kind of patches of black where light is missing your eye. The only time that this actually does happen is, you know how stars twinkle? Yeah, the famous song. Stars twinkle because they are very far away and there's a lot of Earth's atmosphere between you and the star. So light that travels from the star sometimes gets knocked out of the way by Earth's atmosphere and does not reach your eye. So when the star blinks, like when it goes off, that's because the light coming from it has not hit your eye. And then it comes on again because some light from it has hit your eye. So that's why stars twinkle. But apart from stars, light is just shining into your eye from everything all the time. So all waves, because we have talked a little bit about like radio waves, microwaves, all waves reflect off some stuff. But today we're going to focus on light and we're going to focus on mirrors. If you've brought a mirror with you, then it might be, oh, hello, it's good, isn't it? Then that's fun. You might want to look at it, but it's not that important, to be honest. Right, let's have a very sort of simple look, first of all, at how light bounces off mirrors, how you can see things. Here we go, come down here with me. So let's pretend that this person has got a duck above them, right, on their shelf, you know, just a kind of typical run-of-the-mill everyday scenario. This is how you draw a mirror in physics, a line with lots of little diagonal lines coming off it. So this is the normal. This is like a dashed line which cuts the mirror in half. It's not really there, it's just something that physicists draw, scientists draw to help us with this kind of diagram. I've labelled it right, that's the normal. So a ray of light travels from the duck, bounces off the mirror and into the person's eye, and that is how the person sees the duck. Now, it's worth bearing in mind, as we've talked about, what is actually happening is light is bouncing off the duck in all different directions, but we are simplifying, okay? When we draw these diagrams today, we'll just pretend that it's just one ray of light. So an important thing to remember is that light always travels in straight lines. It always travels in straight lines. And also light is shining all over this duck, bouncing off this duck, but we're going to simplify, okay? Right. So I've got a little sheet for you. It might seem simple and obvious, but the answers to these questions are things that a lot of people get wrong, even at GCSE. So if you have been to my Facebook group and you have found the PDF of the printouts that I do, you can do it in the printout. If you haven't, don't worry about it. I made them super simple. You can sketch them if you want to, like Eli, if you fancy some sketches, if you want a record of this lesson for whatever reason, you can. Or you can just have a look at the screen and think, which way am I going to draw some arrows on this diagram, right? Draw arrows on these light rays, that's just the straight lines. Draw arrows on the light rays to show how these fish see their food. One has been done for you. Is this all right? So you've got a side of a tank, yeah? This is the fish in the tank, and the fish has got some food below it, but it can see the food in the side of the tank because light is bouncing off the mirror, okay? So there's just 2 more fish seeing food situations on the screen, and I'd like you to draw arrows to show how the fish see the food. This first one, light is bouncing off the food and then into the fish's eye. And that's how the fish sees the food. And the second one, I tried to do them different way around to try and confuse you. Light is shining from the food and into the fish's eye. And that is how the fish is seeing the image of the food. This seems really obvious, but all the time at GCSE, when I was teaching physics, you'd have people drawing diagrams like this. There's a person, there's a delicious cake. How does the person see the cake? The person sees the cake. And every time you'd have to be like, no, it's not right, is it? It's not right. Unless this person is Superman, this is not an accurate situation. Light beams do not come out of people's eyes and onto things. That is not how you are seeing everything in the room. You are seeing things because light is bouncing off them and into your eyes. It looks weird and painful, but this is the correct scenario. And you'll find it's very tempting to do it the other way around. But light has to go into a thing's eyes for the thing to see the thing. Good, glad we cleared that up. Okay, right, moving on. Let's zoom in a little bit on this angle on the mirror. Superman, yeah, exactly. Superman, yeah. There's someone I'd like to meet. Okay, let's zoom in on this bit here. What's happening here? We'll find out why we need the normal now. Let's zoom in on this bit. There we go. I'm not going to give you the answer. I think you're going to be able to work this out. So this ray here, the one that is bouncing onto the mirror from the duck, has got a special name. And the ray that's bouncing off the mirror into the eye, that's also got a special name. These angles, the one between the normal and the line coming in, that's got a special name. And the angle between the normal and the line going off, that's got a special name. But I think if I tell you the 4 names, you're going to be able to work out which one goes where, okay? So I'd like you to match these labels to the diagram if you can. You've got the words incident ray, reflected ray, angle of incidence, and angle of reflection. Now I'm thinking probably 3 of those you haven't heard of, but you might be able to work out what one of them is. And if you can work out one, you can work out all of them, I reckon. Let's go then. So I was thinking you would probably be able to work out that the reflected ray is the ray that has been reflected. And if you know that's the reflected ray, then you probably know that the other ray is the other name, the incident ray. So the incident ray is the ray that is bouncing onto the mirror, going onto the mirror. So the angle between the normal and the incident ray is the angle of incidence, yeah? You get it. Right. Okay, good. Let's move on. Can you label the reflected rays with an R in each diagram? Can you label the incident rays with an I? And can you sketch the normals? The first has been done for you. So the ray coming off into the fish's eye is the reflected ray. Going into the fish's eye, that's the reflected one every time, right? It's bouncing off the tank and it's going into the fish's eye. So that means that the incident ray is the one shining onto the tank. So always the one between the food and the tank is going to be in the incident ray. And well done if you remembered that the normal is at right angles to, it just kind of cuts the mirror in half, right? We've got to learn a whole law of physics. I wonder if you can work it out. So here's that diagram again, zoomed in. We've got the incident ray going in, the reflected ray going off. We've got the angle of incidence and the angle of reflection. Do you notice anything about the angle of reflection and the angle of incidence? You spotting anything? Noticed anything? You thinking of any kind of fundamental physical law that we could possibly get from this diagram here? You got it? If you've got it, then you got it. If you haven't got it, then I'll tell you, they're always the same. The angle of incidence and the angle of reflection are always the same. Isn't that nice? That is called the law of reflection. There you go. You just learned a physics law. How good is that? Right, quiz time. I'm going to show you 6 ray diagrams and I want you to tell me, are they correct or is there some kind of problem? And if there is a problem, what is the problem? Here's the first one. Here's your first ray diagram. So you've got light travelling in a straight line from the duck to the mirror, bouncing off the mirror and into the person's eyes. The angle between the normal and the incident ray is labelled an I. The angle between the reflected ray and the normal is labelled R. Is that okay? 3, 2, 1. Oh, Hannah wants 12 seconds. Okay, another 3, 2, 1, 3, 2. Yes, correct. Well done. It is. It's fine. Well done, Nor. I like it when people put question marks at the end. It shows you thinking. It's fine? Yes, just to clarify, this one is totally fine. That's the incident ray, the ray shining onto the mirror. That's the reflected ray, the one being reflected off the mirror. And that's the angle of incidence. And that's the angle of reflection. Good. I'm going to try and catch you out though. What about this one? Is that one okay? Hannah, I'll compromise. I'll give you 10 seconds. Is that one okay? Ray of light shining off the duck onto the mirror, bouncing into the person's eye. Angle between the mirror and the incident ray labelled with an eye, angle between the mirror and the reflected ray. Ed is noping it hard. Tasnim, excellent work from you. Casper, yeah, you're right. It's the wrong angle, isn't it? It's so easy, especially if like you're in GCSE and you haven't revised properly and you're a bit panicky. It's so easy to do this. But yeah, the angle of incidence is not the angle between the mirror and the incident ray. Or what would be the point in drawing the normal? It's the angle between the ray and the normal. So well done if you got that. It's very easy to get confused that way. What about this one? What about this one? 10, 9, well done Luke, 7, Stephanie, 6, 5, Amy, no, you'd make a good politician. No, this one is not correct. You had to remember the law of reflection, which I literally just told you seconds ago, so that was really hard. The angle of reflection and the angle of incidence, they are always the same. Ramin, sorry Ramin. They're always the same. That angle is always the same as that angle, same size. Yes, no, correct. So I tried to make it that I is a lot bigger than R, right? So that just wouldn't happen. That does not happen. You couldn't see that duck from that angle if you were stood there. The light would go sort of onto your chin. You'd have to move down a bit, okay? So well done if you got that. That was wrong. Okay, 3 more. How's this one? Is that one all right? 10, 9, 8, 7, 6, 5. Ray going from the duck bouncing off the mirror into the person's eye, angle between the incident ray and the normal labelled R, angle between the reflected ray and the normal labelled I. Nope, says Casper. Well done, Casper. The labels are the wrong way around, aren't they? This is the incident ray, so that's the angle of incident. What about this one? Is this all right? So we've got a carrot with a ray bouncing off it and onto a mirror, and then the ray goes into the person's eye, and we've got the angle between the normal and the incident ray labelled with an I, and the angle between the normal and the reflected ray labelled with an R. Jackie's just shouting, no! Ramin thinks it's fine. Amy thinks it's fine. Eli says, yeah, Eli's still here, that's nice. Yes, it is fine. I was trying to trick you by replacing the duck with a carrot, but you cannot be fooled. Oh, well done. Right, last one. Is that one okay? 10, 9, 8, 7. Pippa is okay, well done. 6. Laurie. 5. It's all good, says Eli. It is, it is. What about this one though? What about this one? 3. Ah! Is that Laika? I'm hoping to have caught you out with this one. Yeah, see, Tracy's saying yes. Emma's saying yes. Is it okay? No, it's not okay. I'm so glad that I fooled you. Did anyone spot why it's not okay? The light is going from the eyes and onto the duck. Oh, see? It's so easy to not notice. Well done, Casper pointing out. Unless the duck is looking at the person, in which case it would be fine, but then this would be the incident ray, so that was our clue. Yes, well done. This is the arrows should be the other way around. Light should be bouncing off the duck into the person, or, as Casper says, not to be human-centric about it, if this is a diagram of a duck seeing the person, then the light is shining in the correct direction, but this would be the incident ray, and that would be the reflected ray. Oh, you guys, always pushing me. I love it. Okay, right. If you've got a mirror, then get your mirror out and think about this really weird question. In your mirror, on your mirror, where is the image on a mirror? Where does the image seem to be? Where does the image seem to be? I'm doing this like, grab the image like a cat. Where does the image in the mirror seem to be? On the mirror. Is it on the mirror, Ramin? Is it on the mirror? Can you like touch it? It's just a weird and beautiful question, isn't it? Just think about it. Where does the image appear to be? The same distance away! Oh, look at that! Yes, inside. It does nod, doesn't it? It seems to be inside. Yeah, it's behind. Yeah, I agree. It seems to be like, you would imagine that if you could sort of put your hand on it, it would be like here. So yes, again, this is something that they will test you on if you fancy doing a physics at GCSE. The images formed by mirrors are, whoops, you've gone a bit wonky. They are the same size as the object, and they're the same distance from the mirror as the object is. Does that make sense? You probably all knew the first one already, right? Like if you're a 5'5" human in real life, then when you look in a mirror, you're still 5'5". It's not like a magnifying glass, is it? We will, if you want to come to my GCSE lesson, we've got a really good lesson on lenses the week before half term that you should come to, where we'll look at how things are made bigger or smaller. But a mirror isn't doing that. The image is the same size, and yeah, it's the same, the object, the image is the same distance away from the mirror as the object is from the mirror, right? So if you're looking in a mirror right now, if you're 20 centimetres away from the mirror, it feels like the image is 20 centimetres away from the mirror as well, doesn't it? On the other side. Yes, good. Okay, we need to look at how to draw images. How to draw ray diagrams so that you see the image, like how a person sees an image. I need to introduce you to somebody. A lot of you have met this person before, but some of you haven't. It's actually a very important thing. It was science mascot. Some of you will know this guy. This is, right, I did a lesson quite a few modules ago now. We did a lesson on reduce, reuse, recycle. And I was teaching people what reuse means and what it does not mean. So taking a glass jar to a weighing shop and filling it with lentils and using that again instead of using like another plastic bag, that is good reusing. And I was like, you go to workshops all the time about reusing and they do stuff like this and it drives me mad. So like, this is not a good way of reusing a yoghurt pot and a takeaway container, because what have you done? You've added more sellotape to it. This is how I ranted on in this lesson about reusing. It's like, you've added more sellotape, you've added glitter, which is plastic, and you've painted these plastic forks, which makes them harder to recycle. So, and it's not like this is a treasured toy, is it? I ranted in the lesson. I was like, you're not keeping this. In a couple of days' time, you're going to want to throw it away, and you've actually made this stuff harder to recycle. This is not reusing things. And of course, everyone in the lesson went, oh, you're so cute, we'll call him Forkish. And now I love him, and you've taught me to love things that I used to find really annoying. So Forkish doesn't fit on my shelves. So he's just been lurking in the background this whole time, but he really wanted to be part of this lesson. So we have to swap the duck for Forkish now. This is how a person would see Forkish on the shelf above them. But how do you actually see the image in the mirror? Well, this is really cool. Your brain knows light travels in straight lines, right? So it sees light coming to you from this direction, shining into your eyes. And it's like, oh, okay, well, I guess the light must have come from over here. And this line of light is dotted, because that line of light isn't really there. That's just your brain imagining that the light must have come from that direction. And then the image gets created for you in the mirror. Isn't that awesome? So there's no actual ray of light. Long live King Forkish, someone's saying. There's no ray of light travelling into the mirror. It's just an amazing kind of illusion produced by your brain. All right. So here's the sheet that I have for you. I think I will do one more example on the board, because I think it's all right looking at sort of computer slides, but really you have to see a human do it and watch their struggle to know how to do it yourself. So I'll do one more example for you, and then I'll set you loose on the Wormy picture, okay? So if you had, like I say, a question in an exam about how does a person see an image in a mirror. So here's my mirror, my flat mirror, drawn physics style with all the lines of it. Here's an eye. Let's keep it simple. And I don't know, what is this person looking at? A ghost! Oh! Ramen, yes! All right. So, there's a ghost. Oh, brilliant. Yeah, I love horror films. So here's a ghost. Yes. Full of surprises, you lot. How is this person seeing the ghost in the mirror? Ramen, I've just realised I'm going to have to draw this ghost backwards. The first thing that I would do is draw the image in the mirror, okay? What have you done? Why couldn't you have said a dot or something? There we go. That'll do. So that's where we know that the image is, yeah? Like from experience. The image is going to be the same distance away from the mirror as the ghost is in real life. So there's a ghost, right. And then the next thing I'm going to do is, well, the image, there's a line going from the eye to the image. So I need to draw carefully a really straight line like that. and the light is going into the eye, so I'm going to put an arrow on it, but I'm going to make this bit of the ray dashed, because this light ray isn't really there, it's just what your eye is imagining. And then, what's the last thing I've got to do? Well, what's actually happening, the reason you're seeing the ghost in the mirror, is because light is bouncing off the ghost and into your eye. So I'm going to draw a normal to help me with this bit. A line cutting the mirror in half. And then if this was like a GCSE, I'd have to really carefully draw this line so that these two angles were the same. Like that. Oh wait, oh, nearly drew an arrow in the wrong direction. There we go. Phew. So I think that angle and that angle are like more or less the same. I think I'm getting away with that. So that is quite a rough sketch of how your eye or how your brain sees an image in a mirror. Is all that okay? I've got light shining from the ghost, bouncing off the mirror and into the eye. That's good. Going into the eye. I've got those angles which are roughly the same, and I've got my ghost inside the mirror, about the same distance away, and I've got an imaginary line going from the ghost into the eye, which is how the brain actually sees things. Whew. Would a ghost reflect though? Casper, a whole different bottle of physics that we're not going to look into today. Would a ghost reflect? Look at people liking that comment. All right, yeah, that's a pretty good point. So here we go. Here is Theatre of Science mascot Wormy. She's got a new shoe. I need you to draw light rays to show how she can see her boss new footwear. Let's have a look at how Wormy sees this shoe then. So yeah, what I would do is I would draw the image first and then draw a line, a straight line from the eye to, well, from the shoe to the eye, I should say really, shouldn't I? From the image to the eye, going into the eye. But then the bit behind the mirror isn't really there. It's just your brain seeing it because it's amazing. So I would do that a dotted line, okay? And then, like someone said a few seconds ago, I'm going to draw the normal in. You don't have to, but it's a good way of showing you that the angles are the same. And then you want a line going from the image to the normal. And that is an actual ray of light. So you can do that as a solid line. And then, yeah, I think those angles are the same. The light's going into Wormy's eye. It's all good. Excellent. So let's keep that on the screen and have a look at the ant one. Draw the image of the pants. Draw a line going from the pants into the ant's eye. Make the last bit of that ray dotted because it's not actually there. And then a normal again. It's a bit fiddly, this, isn't it? It's a bit small. But a line going from the pants to the mirror and then bouncing off the mirror and into the ant's eye. So yeah, again, those two would be the same. The angle of incidence is between the incident ray and the normal, and the reflected ray and the normal. I've got the angle of reflection between them. And I would be checking, are my arrows going in the right direction? And are R and I the same? Those are like the two kind of classic big mistakes that people always make. Poop. Okay, yes, that is the end of the lesson. Thank you so much for joining me. It was really fun. Very strong banter in the comments on these Facebook lessons. I really, really enjoy it. I really do. If you are new, you might not know how. I did say that I would tell you how this works. So everything that I do online is free. I do a Lego Storytime show on Thursdays and Mondays with loads of Lego story and a science activity, and I just tell you all about a thing that I learned, like earwax or black holes or cake or whatever. I do this free all ages lesson, and I do a free IGCSE lesson as well every week during term time. And how it works is a lot of people are supporting me with £5 a month. It's so amazing that it works, but it does actually work. If you press my blue button on Facebook, or if you go to this website called Coffee, if you just search like Coffee Theatre of Science on the internet, then it takes you to this website where you can send me £5 a month. And that is enough, because enough people are doing it, that this can be my job. It's brilliant. This is not very much for people to pay, but I'm getting a wage. It's great. So yeah, if you like to do that, and you can, then I will send you nice things. I'll send you Theatre of Science magazine. The one that I will send you at the moment is on mould. I'll send you a free biodegradable plastic bag so that you can grow your own mould. I know, delicious, and identify it. It's got a comic book about a woman who helped in the discovery of penicillin. I know, like the true story of penicillin discovery. Very proud of this, that's my zine. I've also sent in some rainbow glasses. Hi, Casper's Wormy. They make you see rainbows. They are also amazing. So yeah, thank you very much if you have signed up to support me. Okay, GCSE questions. Sorry, here we are. A woman looks at her reflection. Draw a cross where the image of the bow on her head would be. I'm sorry that it's a blooming woman wearing a bow, but it's the only royalty-free image I could find that worked. Draw a cross on this image, or just have a think about, where is the image of this bow in the mirror? 2 marks for that. Isn't that brilliant? I'm going to give you 5 seconds. So did you draw the bow on the other side of the mirror and level with her real bow? If you did, well done. That's 2 marks. 1 mark for it being on this side of the mirror and another mark for it being the same distance away. Very nicely done. 2 marks GCSE. The next one, can you draw a ray from the bow that reflects off the mirror and into the woman's eye? And draw arrows to show what direction the ray is travelling in. So draw a ray of light from the bow that reflects off the mirror and into the woman's eye, and then draw arrows to show what direction the ray is travelling in. 2 marks for that. And mark the angle of incidence with an I and the angle of reflection with an R. And that is also 1 mark. Three, 2, 1. Didn't give you much time for that, did I? Oh, Casper's done it. Well then. Light reflects off the mirror and into the woman's eye. So have you got that? Light reflects from the bow, off the mirror and into the woman's eye. Draw arrows so that light's going into her eye. 2 marks for that, isn't that good? And then you didn't have to draw the normal, but it's always a really good idea. If you've got arrows going into the eye, then give yourself a mark. And if you've got the angle of incidence and the angle of reflection the same, roughly the same, give yourself another mark. And if you've labelled the angle of incidence correctly with an I and the angle of reflection correctly with an R, give yourself another mark. And the last one, this is the one that was getting my GCSE students quite confused last week. I like this one actually. Really makes you think. Here we go. A mug is placed 20 centimetres in front of a flat mirror. Is the image bigger and 20 centimetres away from the mug, bigger and 40 centimetres away from the mug, the same size and 20 centimetres from the mug, or the same size and 40 centimetres from the mug? Well done, yeah, it is, it's D. But if you said C, that's what all my GCSE students were saying as well. I'll show you on this diagram. Laurie, yeah, no, it's not, but I'm so glad that I caught you out. It's a good one to practice this. And then if you actually end up doing an exam, you'd be like, oh, I know what they're doing here. Yeah, the mug is 20 centimetres away from the mirror, but the image is obviously also 20 centimetres away from the mirror. And the question was, how far away is the image from the mug? So the image is 40 centimetres away from the mug. It's a really horrible, sneaky question, that, because you probably sort of knew and you probably just read the question wrong. But it's a good one. I know, it's good. Everyone loves a GCSE question that catches you out a bit. It's a good way to learn. So yeah, well done if you said D. The mug and the image are 40 centimetres away from each other. Okay, well, that is officially the end of the lesson.